5B, Math 135. There's a couple problems I still wanted to integrate for you. This is similar to what we did last time, where we have the same denominator. So we're going to split it up. We're going to have x over square roots of x plus 1 over square root of x, and all of that to dx. Okay, we'll simplify. We'll bring this to x to 1/2. So x over x to 1/2 plus 1 over x to 1/2 dx. X over 1/2, this is a 1 minus 1/2 is just x to 1/2. And this 1/2 in the denominator we're going to bring up to the numerator and change it to a negative 1/2 dx. Okay, so now we can integrate. We're going to add 1 to 1/2. That gives us 3/2. And we multiply the reciprocal, 2/3. Here we have a negative 1/2. We add 1 to negative 1/2 and we get a positive 1/2, and then 1 over 1/2 plus c. So we have 2/3 x to 3/2 plus 2x to 1/2 plus c. And then if you're required to put it in radical form, 2/3, this is only if you're required to. You have a square root here, and then we're going to cube our x. All right, and this becomes 2 square root of x plus c. All right, very good. Let's go on to the next one. The next one has to do with an e to the x problem. Okay, I want to make sure and show you this one as well before we go on to our new concepts. Okay, so here's an example where we're using e to the x. We have integration of 4 over e to the 2x dx. All right, first thing we want to do is take this 4 out to simplify for us, and then bring this e and change the 2x to a negative 2x dx. Okay, so now we're going to integrate. We keep the 4. We keep the e to the negative 2x, and then we multiply by the reciprocal 1 over negative 2 plus c. And that gives us 4 over negative 2 is negative 2, e to the negative 2x plus c. And then if you're required to have not any negative exponents, we would go ahead and put the exponent on the bottom and change the sign. Okay, very good. So we have some basic integration formulas that we have been working with for this section. There are 4 more, but there's just 3 basic ones we've been working with. So we have some basic integration formulas. Okay, so we're just going to look at 3 of them. And that is, if we integrate u to the r du, then that would equal u to the r plus 1 times 1 over r plus 1 plus c. All right. The second one, if we integrate 1 over u du, oops, I wrote dx, meant to write du, okay. We know that equals ln of absolute value of u plus c. That's if we don't know if x is less than 0, because it needs to be greater than 0 for any log function. Okay, so number 3, we're going to integrate e to the u du, and that's just e to the u plus c. Okay, so into our new concept. When we integrate, sometimes we're not able to just simply integrate without manipulating the problem. And so what we're going to do is use substitution for that. Okay, so basically, we know that y prime is dy dx. Well, same thing with u prime is du dx. Okay, so if we let u equal x squared plus 1, then u prime equals 2x. And we can write u prime, rewrite it as du over dx equals 2x. And that's going to come in handy when we use substitution. Okay, so let's do an actual problem. we're going to integrate 2x square root of x squared plus 1 dx. We haven't integrated in something like this before. So let's let u equal x squared plus 1. Then du, which is the derivative, du dx, is just the derivative, which is 2x. Okay? Well, we're going to rewrite this, multiply both sides by dx, and we end up with du equals 2x dx. That's multiplying both sides by dx. And this is what we're going to be using as part of our substitution. Okay, so what do we have so far? If we put a u in here, we're going to integrate square roots of u. But to integrate a square root of u, we need a du. Now notice what du is. Du is 2x dx. Well, look at this. There's our 2x and there's our dx. So we've covered everything. We've got in our du, we have our 2x and dx, and our square root we just replace with our u. Now we can integrate. Of course, we know this is u to 1/2 du. Integrating, we have u to 3/2 times 2/3 plus c. And now we can go ahead and put back our x squared plus 1 into our u. So that's 2/3 x squared plus 1, 3/2, the power of 3/2 plus c. Okay, so let's do another one where it doesn't come out so even. We're going to have like, we have to use our brain a little bit more than that. Okay, so here's another one. We're going to integrate 6x square root of x squared plus 1 dx. All right, since you have this underneath the square root sign, we're still going to let u equal x squared plus 1, and du is 2x, du dx is 2x. So du is 2x dx. Okay. Well, we're going to integrate. We put our u under the square root sign. But wait a minute, our du is only 2x. We've got a 6x. A 2x is not a 6x. So what we need to do is multiply both sides by 3, and we get our 6x dx. So now we have to use 3 du. So I'm going to put my 3 here and my du there. Okay, so we can go ahead and pull our 3 out, change our u to 1/2 du, and begin to integrate. So we keep our 3, we add 1, and we get u to 3/2, multiply by the reciprocal, 2/3 plus c, and that's just going to be 2u to the 3/2 plus c, and now we have to replace our u with x squared plus 1. C, not too bad when you break it down step by step. Okay. So let's see what we got. We're going to continue, do another problem. We're going to do a couple more, and then I'm going to have you start on your homework. But we're going to break down the homework. Okay, we're going to do partial homework. So we have 3x squared times x cubed plus 5 cubed dx. All right. Integration of 3x squared times, parentheses, x cubed plus 5 to the 3rd power dx. Okay. So let's take this inside, and we're going to let u equal x cubed plus 5. Then du dx is 3x squared. Multiplying both sides by dx, we have du is 3x squared dx. Oh, that fits nicely. Here's our 3x squared, here's our dx, and we're just going to put our u in there. So our u is going to be u cubed du. Du covers the 3x squared and dx, and the u covers the x cubed plus 5. Okay, so integrating this, we add 1. We have 4, divide by the reciprocal, divide by 4, multiply by the reciprocal, okay, plus c, and then we replace our u, which is x cubed plus 5 over 4 plus c. You are to the fourth power. And it is okay to write it this way. I'll accept either way in a test. Okay? All right. Let's do another one. These actually kind of get fun. They're like little puzzles when you're sitting there going, what am I going to let u equal so that this works out? Okay, so here's another one. We're going to integrate 3e to the x over e to the x plus 2. I'm going to sit and ponder for a minute. What are we going to let u equal? Well, this is the one that might bother us the most. Let u equal that, see what happens. E to the x plus 2. All right, well, du dx equals e to the x dx. Oops, just e to the x, sorry. Now we're going to multiply both sides, and we get du equals e to the x dx. Okay, so we're going to utilize this. Okay, so we said this was u. All right, that's u. If we put in du, du is e to the x dx, but we have 3 e to the x dx. So we're going to need a 3 du. Okay, it's like a little puzzle. All right, from here we pull out the 3. We're integrating 1 over u du. Keep our 3, 1 over u du, change to ln of u, absolute value of u, plus c. Okay, so ln of u, we're going to put in u in there, e to the x plus 2, e to the x plus 2, plus c. Now we know e to the x can never be a negative number. Therefore, this will never be a negative number. So it's okay for us to write it as 3 times ln e to the x plus 2 plus c. Okay, let's do one more, our last one. All right, last one. We have x cubed over x to the 4th plus 1 squared dx. So take a guess. What do you want your u to be? Correct. We want our u to be this because when we take the derivative, we're going to get that. Very good. So u equals x to the 4th plus 1. Du dx equals 4x cubed. So multiply both sides by dx. Du equals 4x cubed dx. Oh, but wait a minute. We have a dx, we have a 4x cubed, but we only have an x cubed. So we're going to have to handle this differently. We're going to have to divide by 4. 1/4 du is 1/4 times 4x cubed dx. And that gives us 1/4 du equals x cubed dx. And that's what we wanted, because there's the x cubed and there's the dx. All right, so let me state that again. Because we had a 4 next to this x cubed, we had to get rid of it. So we divide both sides by 4, and that gets rid of it. So now we have 1/4 du. So when we write our integral, we're going to have 1/4 times 1 over u squared du. Okay, we can pull out the 1/4. We can bring up our u squared to -2 du, and then we can begin our integration. We have 1/4. We're going to add 1 to 2, which gives us a -1. And then what do we do from there? Well, we're going to divide by a -1, multiply, plus c. And then we have, let's see, 1/4, -1, add 1, we have -1/4. U to the -1 plus c. And now we're going to replace our u, or we can put it down below. Put it below and fill it in with x to the 4th plus 1 plus c. Okay, so now we're going to do your homework that I'd like you to do now, and then come back when you're done with that homework. All right? So for now, do 1 through 11.